Okay, also jetzt bin ich dran mit meiner binäre Scheiße. Wir wollen JavaScript. Es gibt kein HTML5, kein JavaScript. Echte oldschool binär. Die Sache ist, das war ursprünglich so ein Workshop für die Gruppe 4 Stunden. Da musste ich das in 2 Stunden anpacken. Jetzt muss ich das in 1 Stunde anpacken. Das ist immer so Powers of 2. Ja? So, es wird ganz viele Demos geben. Das ist das, wie Michael gemacht hat. Das sagt, okay, das ganze Kram weg, ich mache ganz viele Demos. Ja? Und die Sache ist, ich habe das schon mehrmals gemacht, immer auf Englisch. Also ich werde das, wenn ihr nicht dagegen habt, auf Englisch machen. Ja?
Synchronisch.
Das war genau meine Frage. Hier jemand überhaupt kein Englisch kann?
Ja, dann Klingonisch.
Also Klingonisch wäre fantastisch, aber eher nicht oder so. Hardcore. Okay, also, very quick, yeah? Who am I? This is not really important, so I'm going to do it like really quick. Okay, I'm a nerd. I like zombies and Cylons and all that stuff. I'm a geek. I like reversing. Of course, Python, of course, that's why I'm here. And I like animated kids. Like it. Give me 10 seconds. This is my shameless flag. Yeah, we are hiring. I'm from this company and runs and we're security people, very highly specialized, so to say. We do like everything, every single fucking thing. We do hardware, mobile, binary web, binary would be my thing. Source code analysis, network, everything. Yeah. So yeah, it's actually pretty cool because you have paid time for research, and then they actually push you a lot. They send this thing that you did to conferences. We want that you go somewhere and say, hi, I'm Carlos, I'm from Engrams, and I did this cool shit. It's kind of, they call it like a smart marketing. It's really cool. Yeah, of course, consultancy, so you cannot have like t-shirts like got root and stuff. But anyway, it's pretty cool. So if you're interested, just talk to me after this, okay? So, to the point, agenda, what are we going to see? Yeah? The whole thing here is we have binaries, fucking syntax. we have binaries, whatever kind of binary program, and then we would like to know what is happening when this runs. Because usually what you do is you have your binary, you click, and it runs. And then you say, well, cool. But what if you want to know what is happening actually with this binary? This is what we're going to check. Yeah? And I have like 3 different sections. I'm going to talk to you about Binary Debugger. This is a really cool thing. This is how to use Python to debug a software without a debugger. We're going to take the debugger out, and we're going to debug it. And everything with Python in Windows. Then I'm going to talk to you about Intel ping, and this is where I lied a little bit, because this is not Python, this is C, C++, Cram, but it's such a really cool thing that you have to see it. And it's related to the other one. And then I'm going to talk to you really quick. I'm going to show you an example of this BDay framework. This is something similar as well. How to do just with Python some kind of debug or debugs an application. Okay, and then you're going to be free. Well, why Python? Because Python is awesome. You can see here the guy saying, oh, but you're flying. I just typed import anti-gravity. It works. It's an old joke. But Python is awesome. How many of you use Python or used once Python? Good, very good. What about you? Ruby guys, eh? Okay, so we have debug. Good. It's a pretty cool framework. The thing is, I'm not really good at structuring things. Yeah? So I say, oh, I'm going to talk to you about Binary Debugger, and then I'm going to talk to you about another thing. Why? Because Binary Debugger is like so to say, it didn't really pop up. Yeah? Oh, look, a framework to debug stuff in Windows. It's like a kind of the evolution of this another framework that's called PyDBG. Does that say anything to you? So PyDebugger? No? Okay. Do you know that book? This Hacking with Python. This is a really, really good book. You should read. So before we have debugger, there was this kind of the same thing but old. The problem is it's really cool, but you need Python 2.4, Python 2.5 maybe. You have to hack it a lot. So it's not really usable right now. But anyway, you can do a lot of really cool stuff with it. For example, this thing. Everybody knows keepers. Yeah? Chris, show us keepers. Do you know keepers? Yeah, yay. Of course you know keepers, yeah. Okay, the thing with keepers, it's actually a pretty good software. Your passwords inside are really well protected. But it's the same thing like the Mimikatz. Somewhere, somehow, your data is unclear. It's in clear text somewhere in memory. If you know where it is, what you have to look for it, then you can just fit the jackpot. Yeah? And this is what I did with this framework. And this is really old, so I don't have to install it anymore. I'm going to show you a really short video. And what I'm going to do is I'm going to use just a Python script to attach to keepers and just look for calls to this specific function. Yeah? This one here that says set clipboard data. This thing is a pointer somewhere in memory where there's a string. That's exactly the your password in clear text. Not exactly. What happens is your passwords in keepers, because I see some faces like fuck. Your passwords in keepers are really secure. Okay? But at least how I use it, keepers, you have to copy the clipboard, and then you have like 30 seconds to say this password is going to auto-destroy in 30 seconds. And then you copy it to whatever website, and then you use it. After 30 seconds, this password is not in the clipboard anymore. The problem is somehow keepers has to copy the clear text, the password, to the clipboard. And it does it using those functions in Windows. This is just the Windows API for the clipboard. Yeah? And especially this one is a really important one, because this is your password decrypted for you by keepers. So it's a really cool thing. But I'm going to show it to you. Yeah, this is just a kind of a screenshot from the code. It's not really important. You can see here just thing. It's actually pretty easy to read, because it says something like read process memory at this address 4 bytes, etc. Yeah? But this is not really important. I'm going to show you, end the video. Do you know this lady?
There's no lady. Hey.
Damn it! Okay, thanks. I'm going to show you the video. The lady. Do you know this lady?
Futurama.
Very good. Okay, this is the video. It's just 1 minute. This is a sample database. Yeah? And I just show you, okay, you just do a copy password, the password from the clipboard. It's test password. Really does it. Okay. Then, but this is really stupid, because I wanted to show the code, and then I used this color scheme, so you cannot see anything. Very good. Okay. Then you have keepers. Then you use this script that is just a debugger implemented in Python. Then it says, okay, I found keepers, and it's right now attached to it. Yeah? And every time you copy to the clipboard, you cannot read it here, but it says, okay, credential copy to clipboard, test password, or test user, or test password, or whatever. Yeah? The thing what this thing is doing is it knows exactly those functions, it's attaching to keepers, and it's monitoring, and every time that you copy something to the clipboard, then it stops and says, okay, I know that the second argument from this function is a pointer to this password, so just go to memory, follow this pointer, and reads the memory. So it's that easy. It's actually pretty easy. So this is very shitty. Because imagine the scenario where you have your machine has been compromised already. Somehow, okay? And then, like Chris did, then you have a metapreter, so to say, yeah? And you have a console, but there's nothing interesting in that machine at the time. What you can do is you can put this in your machine, you can make it run, wait for keepers all the time, and then every time, silently, every time you use keepers, it's going to read the passwords that they copied. Yeah? And then you can do, I don't know, like send it through UDP or whatever. Not scared. You are not scared, are you? Okay. It's okay, I have more stuff. Okay, so this was just a little example using this PyDebugger. That is the old version. Yeah? This is the new version. And do you know actually how many of you, let's start from the beginning. How many of you have used a debugger? Like every fucking one. Okay, very good. So do you know exactly what has happened when you're using like only debugger, so to say? What is that? How can it be that the debugger can't do this stuff with the software? Can stop it and set breakpoints and all these things? It's actually pretty easy because a debugger is just like any other program in Windows. I'm talking in Windows, about Windows. A debugger is just like any other single program in Windows. It just makes use, it uses some API. There is a debugging API in Windows. You can go to MSDN, you can check debugging API. And there are all the functions. These things are already implemented. Yeah? So the debugger is just a program, in this case like all debugger, it's just an interface using some Windows functions. So it's not doing any magic actually. So the thing is, okay, if the API is already there, the debugger is just a program interacting with the API. I can just take the debugger and interact with this API in any other way. In this case, with some Python framework. The thing is, this way you can go like directly to what you want. For example, in this case, it wasn't really interesting what the keepers is doing. I knew I want to do this when and only when this function is executed. I want to read the second argument. It's a pointer, and I want to go to this memory address and read those bytes. I mean, this is for the cases where you really know what you want, and it's pretty clear. Okay? So this is the thing with Binary Debugger. It's just a wrapper in Python interacting with a Winter2 API, like any other single program. No? Cool. Okay, it's very cool. This is Python. It's written by Mario Villas, by the way. This is Mario. You cannot see Mario. Okay, you cannot see Mario, but you can see Mario in the slides. The whole thing is if you see Mario not here, but wherever other corner you buy Mario here, okay? Because he did this whole thing alone. And it's really amazing. It's a lot of work. So please buy the computer. So we have debugger. This is all that I'm going to say about the theory, and just going to show you some examples. Okay? Those three examples. I have three scripts. Actually, this is the important one, and those two are like small variations from the first one. Yeah? The first one is a tracer. It's just going to say, they're going to use it in a running program, and this is going to write a list of, okay, all those functions were executed. Then this one is called what the fuck DLL, and this is a really interesting one, especially if you're working with malware. It's a pretty cool one because we're gonna see it in action. It's gonna tell you which DLLs is this program loading at runtime. Yeah? This is something that if you try to analyze statically, you don't see those functions, you don't see the functionality at all, and which functions exactly is using. Yeah? And then I'm gonna show you this. Yeah. This is actually this one, but instead of giving you a file, because it's really boring, it's gonna make some kind of picture, some kind of binary art. Okay? We're gonna see it in action. So this tracer, again, the idea is the following, and I'm gonna ask you something here. So the idea here is, I'm gonna tell this script, hey, check this program that is running. I'm gonna use putty all the time. Yeah? Check this program and make note of every single function that's been executed. Yeah? So it's Python, so it's really cool, but it's Python. So you have performance problems. You can imagine every single function a binary is executed. Those are a lot of functions in 1 second. Yeah? So you have performance problems. This is, so to say, the same. It's pretty slow. And I'm going to need to give to this script another auxiliary function that is exactly the addresses of all functions. Okay? And I need to get this somewhere, for example, from IRAPRO or something like that. So I need to do prior to this kind of a static analysis. So that's not that good. Yeah? It's one of the minus points. Yeah, but it's Python. So it's like 500 points. And when you see the other Python with this graphic output, that's really cool. So at the end, it's like a bazillion points positive. That's really cool. Yeah, this thing makes more sense when you're in a workshop. But just so you get an idea how the code looks like. Yeah? So you realize it's actually, it's not like you open C++ code or Ruby code or something like that. Just do it. Yeah? If I give you 5 minutes, if I give you 2 minutes, you tell me where to do it. Yeah? Because the names of the API is something like system find processes by file name. Well, it's pretty clear. Yeah? And you see here it's adaptation to this process, and then it starts kind of the feedback loop apply. Okay? Yeah, more code. This is actually the only thing I'm gonna say about the code is the framework is actually all those frameworks are similar. It's kind of event driven. What you do with this, you have some background in programming. Yeah. Okay. So what you do actually is more like registering callbacks, and then with whatever event happens, then it executes those callbacks. So this kind of model is event driven. Yeah. Okay. More code. I'm going the other way. Yeah, that's all code. Okay. And then you see here, for example, it's just setting breakpoints and every single function. Yeah. And when those breakpoints are hit, then it's just a callback, and then it says, okay, write this address for file, or write this address for the database, or whatever. And here comes the question. Semtex, this one is for you. By the way, also die Sache ist, ich habe das so auf Englisch so oft gemacht, aber die Fragen oder so, das macht jetzt keinen Sinn. Okay, why in hell do I want to do this? Why do I want to trace execution? I mean, it's like really nice, but why? Why is this useful? Semtex?
Das war nur so spät heute.
Vielleicht schwache Funktionen in String-Code zu finden oder um, wenn du eine Schwachstelle hast, zu gucken, wovon wurde das aufgerufen, zum Beispiel die Quelle zu finden vielleicht.
Sehr gut. Ich habe leider keine Schokolade.
Er hat gesagt, ich soll das sagen, ja?
Ich habe leider keine Schokolade. Yeah, that's exactly the point. Imagine, for example, to play a CTF, It looks like a really stupid thing, but it's somehow it's quite important. Any of you play like capture the flags? How do you do with the binary challenges? They're always like a bitch. With this thing, it's pretty easy to trace what happens if I. It's the usual example. Give me the correct, the right password, and you type something, and they say, "Oh, wrong, you're so lame." Yeah, with this thing you can trace which functions are executed, and then you can see, okay, I just went this way when I wanted to go this way. Then you see where's the point where this thing goes to the right leaf or to the wrong leaf, and then you can check here the conditions. Yeah, what you're supposed to write. As an example, yeah, this is actually binary analysis, but just play. For fuzzing, this is really important. Because how many of you have done anything with fuzzing? A little bit, just okay. Even if it's just a little bit. A very important thing with fuzzing is what I see is a lot of people put all the intelligence and all the effort in. Let's generate perfect test cases. Let's mutate very intelligently this PDF and whatever. But they trace what is happening to the PDF reader. Not that good. And then what happens is you have a PDF, you open it with reader, it crashes, and then you don't have enough information. You really don't know what is happening. This is exactly what you meant. And if you have a really good traces for how was the execution, then you can better analyze and find maybe a vulnerability in the code. Yeah? Of course, to impress chicks, this works every single time. Tons of things. Yeah. Okay, but blah 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 blah. Let's do stuff. Yeah. So let's go experimenting, not cooking methods. Okay, as I said, I'm gonna use the whole time putty. I use it for all the demos because it's really cool because it's really small. Yeah. So those things are really slow. So I'm gonna do the following. Putty is open, and I just want to attach to putty and just start monitoring all the functions that have been executed. Yeah? So somewhere. I'm gonna find it. Boom! Old school logo. Okay, I'm gonna say to this tracer the program you have to look for is putty. So exit, and then this is not that relevant. And then I'm gonna give this function file that I told you before. This is one of the things that is not that cool with this solution. This just addresses from the functions. Huh? Starts here, ends here. Starts here, ends here. Okay, so I'm gonna do this. Use here, it says, look, okay, cool, I installed 1,000 breakpoints, or whatever. There's a breakpoint in every function at the beginning. Okay, so now I'm attached to putty. So I'm gonna do like nothing. Just clicking here and then going up. Then I get this file. I just did like nothing. Take a look at how many functions we have here. Like 53. Okay. You cannot do a lot with this text file. Then you have to find a way to represent this so graphically somehow. Yeah. And that would be this modification of this program. There's called this tracer DOT. Do you know this dot language? Yeah. Yeah, of course, because you're a physicist. Okay, so you have to do a lot of things with graphs. Okay, I'm gonna run it. It's exactly the same. What you see is exactly the same, and it's really slow. So I just have a trace. I just generated a trace. So you have an idea how this looks like. What I did was exactly the same. I just clicked a button or something, and then I went out. Yeah, so not a lot of action here. Okay. not a very practical solution. Yeah. Well, you cannot actually see that every one of those is one function being executed, not the best one. And you see here, okay, this function called this function, and then this one called this one. Yeah. It's not the best solution. There's ways that you can change the layout, so it's not that it's spread and it's a little bit more compact. But anyway, yeah, it gets pretty big, pretty easy. Yeah. So, but there's another way. So there's other ways. Okay, and then, by the way, sentence. Do you have an idea why? Tell me another interesting thing I can do with those traces. Everybody go home. Everybody go home. So imagine.
Hook functions, maybe?
Again?
Hooking functions, maybe.
Yeah, but what I'm looking for is something that starts with differential and ends with debugging. Exactly, differential debugging. Very good. think about this. Again, this example from the CTF. Yeah. But one thing that when you're reversing dynamically, yeah, like in this case, it's pretty complicated and very important. Is how binaries are huge. You open a binary, you have 1,000 functions. Yeah? And how you find exactly, let's say quickly, how do you find quickly which functions are interesting to you? Yeah? In this case, small example, you have one of those CTF. You have a Windows window, and then it says, okay, enter the password, and then you click login or check or something. Yeah? And then the program internally is going to check if this password is the right one, and it's going to say, yeah, right, and then you get the point, and then you win. The interesting thing here is what is happening when I click the check button exactly after that I click the check, because then it's going to do the interesting math on your input. Okay, how do I find if this has like 2,000 functions, which 10 are the interesting? What you can do with exactly this problem, actually I wrote this problem for this, what you can do is the following. You run it once, and then you start touching everything. You write things, you move the window, if it has like drop-down menus, you click everything, you exercise everything. But you never touch this check button, never. So this is never to exercise. Then you do it again. You save this text file, and then you do it again. And you just click the check button. Then you have two traces. One of them is like huge, and has a lot of functions that are not really that interesting, are like graphical user interface and stuff. And then you have one other trace that is like 50 functions, or 100 functions. And one of them, or 10 of them, are the interesting. Are the ones that were executed when I click check. What you do now is you just use the first one to filter the noise from the first one, from the second one. And then you get, if you're lucky, like another 10 functions or something. Then you can go to either Pro and check those functions, or 10 functions you can click, and say, okay, this looks pretty interesting. It looks like this one is doing some math or something. That would be an example. And this is way more important than it looks like. So if you use this, you're going to be much better playing CTS with the partner and stuff. Okay. Okay, this is just the code from the last one. This is just a little modification. What I'm going to do is I want to know, is my binary, I just open my binary in either Pro, and I saw, funny, it's not using any network. Nothing. There's no function with the network. It looks like it is not using the network, but maybe it is using the network. Maybe what it's doing is once this binary runs, it's loading all the DLLs, and using some functions at runtime. And this is actually in extreme what malware does. Yeah? Have you done anything with malware analysis? And I'm looking at you too, because it looks like you did. Have you done anything with malware analysis or reversion or something? No? Okay. Yeah, I'll show you this one. Let me show you in 2 minutes. What is happening? I'm gonna use putty again. Huh? And putty is not malware, as far as I know. It looks really shitty. Putty. Everybody involved. Okay, so I'm gonna use this. What the fuck it is? Exactly. And here I just say, okay, again, the program you have to look for is this putty.exe. And you can filter for DLL, but I'm just gonna say all of them. Yeah? Okay, so there's something going on already. There's, so there's loading already whatever DLL, and using a function. Okay, I'm gonna try to connect somewhere. Think about it. Right now, I'm like with a debugger, but without a debugger. I'm attached to putty, to the process, and I'm just monitoring. And every time I see, oh, it's loading a DLL, then I'm gonna log this somewhere. So I'm gonna try this. Next second, and you see suddenly here, it's loading tons. So one DLL and it's loading tons of functions. And apparently, this data path is going to start arriving. So putty is apparently using like a really high level API, use Windows sockets and all that stuff. But if you check this statically, if you check putty in either pro, you're not going to see this because those are not imports. This is loaded at runtime. Yeah? So you're going to miss a lot of information if you just do it statically, like everywhere. Okay. This would be really important or really useful if you are analyzing malware. That's an example. Okay. So I know exactly how it works. How are you doing? But like right now, like, oh fuck, man. Okay. From the three parts, the other two are smaller and are more dynamic. Yeah. Or it's like this. I know because it happens all the time. So quickly, something with Intel pin. Intel pin is really awesome. No? You know this guy? It's not Dave. It's not Dave. It's like the Dave 20 years. You know. Okay, you know who this guy is? Which show? Very good. Have you seen everything? No. Incredible. Okay, Intel pin. As I said, this is not Python, but these are really incredible stuff. It's a little bit different. This is a thing obviously from Intel. I just want to show you one example. Yeah? Usually there was two examples. The first would be a way more efficient tracer. It's the same thing. You're gonna get exactly the same information, but it's way faster and it doesn't need this file with the addresses. Because Intel pin is a framework for dynamic binary instrumentation, and it's from Intel, of course. They know how the processors are because they do the processor, so they know perfectly how this platform works. And it's really, really intelligent. It actually understands, oh, this is a new function. Or, oh, this is a basic block inside the function. You don't have to give any external information. It understands the binary. For example, it works with this self-modifying code, like Packers and all this stuff. So it works. It realizes, oh, right now there's a new function. This wasn't here before. So it's really good. So, yeah, as a demo, it really doesn't do anything new. We're going to do this thing. That's really cool. We're going to detect that we are being hacked, we're going to detect a buffer overflow while it happens, just with Intel pin, okay? So, how many of you have done anything with exploitation in Windows? Really, really basic stuff, like the first 2-3 chapters from the Corelland training or something like that. This is nothing more. Okay, so some of you. Good. Exactly. How I'm gonna do this? How I'm gonna realize, hey, I'm being exploited right now. I'm just gonna check all the time where in memory am I executing, and then I'm gonna check if this address in memory, those instructions that I'm executing right now, are they inside a code section or are they somewhere else? It should not be somewhere else. You know, the binaries, when they're loading memory, they have like different sections, and it really depends. But all of them, they have like a code section, sometimes called text, where and this is where the assembly that you see in either progress. This is where the instructions that you execute are. And they are always like, it begins here, it ends here. And this is all the code. You cannot be executing things here. Yeah? And then you have another sections, then you have data, then you have tons of them. Yeah? Then you have the heap, then you have the stack. Those are the cool ones to exploit stuff. But those are not code. Yeah? So the whole thing when you're doing some kind of like here, when you're executing some exploit, is at the end you start executing code outside the code. You're executing code that is located where the data is. Yeah? Okay, so this is what we're gonna do. Just a little bit, so you see how the code looks like. It's the same idea. So you just register kind of callbacks. When something happens, those functions, your functions, are being executed, and those functions can do anything. For example, write to a file. Or in this case, check if this is a code section or not. Yeah? You can do whatever you want. This is just so you see, it's not that friendly anymore. Yeah? It's not the Python. But it's okay, it's really, really powerful. Okay, so here is an explanation of how it's going to work. In this case, it's an ECH override. The ones that did some exploitation, you know this technique. That's really useful. Okay. Good. So this is what I'm gonna use. Just something simple. And just the idea is not mine. It's just really cute. And it's a really cool block. And the coolest thing is really good technically. The good thing is it's a woman. One of the few, but it's a woman, Julia or something. It's really good. So here I have like a screenshot that explains what we're gonna do. Blah blah blah. I'm gonna show it to you maybe dynamically because this is less interesting. Okay, so I'm gonna go to the virtual machine. To the virtual machine. Okay. Show it to you. Dave, how am I doing with the time?
20 minutes.
Yeah?
20 Minuten.
Go, that's good. Okay, so let's be focused. No, thank you. Some months ago, with a company, we had to organize a CTF for an event in Berlin. So we all did like levels, and I did these exploitation levels. They're like quite easy. And so I took this as an example because it's a really small binary, and it's called vulnerable. And I'll show it here. Yeah, thanks. I just say, okay, this binary, I give the port, the TCP port. It's just a binary, it's gonna listen a TCP port, then I'm gonna send a packet, a specially crafted packet, then I'm gonna exploit the whole server. Yeah, of course the port is like lit. It's not really relevant, but it looks like the logical choice. Okay. and there's something here listening in this TCP port. Good, that's good. And then I have the exploit. It's not really important. It has this specific packet structure, and then you recognize this is up to no good. So this is exactly the payload. So my bad payload, and then I'm gonna just I'm gonna override the stack. Yeah? And with this, I'm gonna override a lot of pointers that I should not override. Okay, so I'll just show it to you quick. I just say send this packet. This I'm gonna do it pretty local, so the local host to this lead port. And then I'm gonna do like this. Oh, calculator, fantastic. So the program is dead, and then I execute my own code. There is the calc. Climate. No, not really. No. But it's like the demo payload. But you see that something is actually working here. Yeah? So I managed to exploit this server. There was some kind of vulnerability. Okay. Let me show it to you. Okay, this is the press. Just a little bit slower, so you see what's happening. I'm gonna start this again. Listen in the same port. I go to my debugger. This is just an old debugger like tune. That's cool. I'm going to attach here. My name is vulnerable.
What's the name of this debugger you're using?
This is just
debugger.
this is all debugger with a lot of plugins and better stuff. So okay, let's go vulnerable unattached. Here. Okay, and I'm just going to set a breakpoint. Okay, can very well be no. And the one that know this exploitation technique can recognize this pop red thing. Yeah? And that's why I'm putting a breakpoint here. Okay, so I'm just gonna let it run. So it's running as normally under the debugger. And then I'm going to send this packet again. So this bad packet. Boom. So the packet arrived, it's processed. Somehow it's too long. It's way too long, and it starts writing and overwriting a lot of information on the stack. Yeah? A lot of pointers they're going to be used later. And one of those pointers is this structure exception handler. I'm going to override this with one address, and I'm going to make it jump to this address. Like I'm oversimplifying everything. But the thing is, I'm going to write a lot of stuff. There are some pointers on the stack that says if something wrong happens, go here. I'm overwriting this with an address that I like. So when something happens, and it's going to happen, it happened already actually, it's going to jump to where I want. And this is exactly where I put the breakpoint here. But realize this, where are we right now? You see those addresses are like 0040 something. Yeah? So this is code. This is the code section of the binary. Yeah? So I'm just going to let it run a little bit. Bam, bam. Okay, so right now I'm somewhere else. Those addresses are not like 0040, they're 0012 something. And those are in Windows and 32 bits. Those are very typical addresses for the stack. So right now I'm executing code with all this is my payload. About all those funky bytes before. This is the code that is popping the calculator. Yeah? But the important thing is I'm not inside a text section. I'm not inside code anymore. because I just managed to overwrite some stuff and make the CPU jump to somewhere else where my code is. But my code can never be inside the code section because you cannot write it there. So this is some kind of data section where my packet data is. Yeah? So the really important thing is I'm not in a code section. Yeah, if I just do like this and then let it run, yeah, it crashes, and you have the calculator. So that's exactly what we saw before, but now a little bit bigger. Yeah. Okay. Very nice. What can I do now? I'm gonna run this program again, and you not again. I'm gonna write this again, but now under this pin framework. Okay. And it's exactly the same thing, but right now what it has here. You see this DLL, this pin tool, EIP trace DLL. This is my code. My code is bit compared to a DLL, and then I say to pin, run this program with those arguments. And by the way, here there's a DLL. There's my code that is going to tell you how to modify the program and check it. Yeah? So this is what I'm going to do. So, run it here. And now, I'm going to send the packet again. Okay. The program dies, but there's no calculator. So it looks like my payload didn't execute. It looks like that. I don't know where it happened, what happened actually. But then I have this text file here. It's huge. It's just checking, okay, I just loaded DLL. DLL has this code section from here to here. I'm going to save this, etc. Then it's going to say, whoa, I'm just executing code here. Yeah? At whatever module, I don't have symbols. And right at the end, it's saying, where's that? Right at the end, it's saying, okay, I'm here, it's code. I'm here, this is where I put the breakpoint. So I'm still inside the code section, and then it says, oh, I'm here. And it's not a text section, a code section. I don't know where I am. This is not a code section, so I'm going to stop everything right now. Then I'm going to die. Because, just die. Because this is not normal. It should not happen. When you are executing code outside code sections, either you're being exploited, there's some exploit thing going on, this is 99% of the time, or you're using some old Adobe product. Those are really funky stuff with binaries. It's jumps and whatever. That's why this Emmet thing in Windows that gives some kind of security measures to all products, it doesn't work with some Adobe stuff because they're just funky. Okay. Very good. So that was with pin. Yeah? And pin, this is really a very small example because pin, it's huge. Actually, with pin, what you can do, it was developed internally by Intel, and they used it for a lot of tools internally, Intel. And they even do some kind of things like, they have a processor and they say, it would be really nice if we can add this instruction set to the processor, but they don't go to production and just do like 2 million processors. What they do is they emulate this and they add some functionality with Intel pin. So it's magic. It's magic. But it's incredible the things that you can do. Yeah? Just a very short example. Yeah, and some code. This means, oh, let's do it. Let's experiment. I did it already. As I said, I'm not really structured. And this is the last part. And they're going to be really quick, but the demo, I like the demo a lot. This is called BDay, and it's just a part from a really huge framework. It's called BDay. Do you know the company Mendiant? The one from the APT report? Yeah. That one. Mendiant used internally a lot of BDay. I was talking with Michael Sikorsky, the guy from Practical Malware Analysis, the red book with the alien, that guy. And they say we use a lot of BDay. And yeah, Exactly, I said that already. That means, wow, this is what the cool kids use. Yeah? Those are the cool kids from which film?
Hackers.
Very good. This is what the cool kids use. So it's like really the bleeding edge, yeah? But not everything is cool. Okay, it's Python, so it's awesome, yeah? And it's this is like Winamp debugger, but it's not just only for Windows. It's for Windows, for Linux, and it's not just from x86. It's from FM, PC, Power PC, everything. Yeah, it does everything. As I said, it's the bleeding edge right now when you want to do some debugging binary analysis. Whoa, it's super cool. Yeah. The good thing is Python. It's really well written, so you can read the code like pretty easily. The bad thing, you have to read the code. It's not there's some kind of wiki, and you click there and you go to do, and you click somewhere else and go to do. It's easy to hate only because that. So I'm always with those guys like, why don't you write documentation? Some guy bitching around. They don't care. So the example, it's going to be really quick and painless. It's exactly the same idea again. Firefox. I'm going to use Firefox. It's just because it's really well documented. So I'm going to use Firefox to do the following. I have a small Ubuntu server, and I'm going to use the Firefox to do an HTTPS connection to a web server. I have an Apache. Good. So it's HTTPS. So it's SSL. So it's secure. Actually, it's secure. But again, the same thing. When it goes to the network, it's already SSL. So it's cool. When I write the things inside the huge memory block that is Firefox, then somewhere the things in clear text, they're not SSL yet. And those are the functions. That's why it's really cool to have documentation. How do you do SSL in Firefox? And then you get those functions. You see those PK11. So this PKE functions. Those are the functions that get my raw data, and they SSL the whole thing, and then it gets to the network. Yeah. And if you see this function, here is a fifth element, like the movie. This is data, and data means clear text data. So this is the function that gets my username or my password or whatever in my Firefox, and then it starts doing the whole SSL cipher. Yeah? So if I get this function inside Firefox while it's running, I just check the fifth element. It's a pointer as well. I just go there and I read the whole thing. So again, think about this as the malware is already in your computer. When the malware infected your computer, there was nothing interesting. Just wait. Just wait. You're going to go to your bank eventually. Okay, so I'm going to use this really cool website. This is not the real Berlin focus. I just, I know how to write a form in HTML. That's all. So I did this. Yeah? And as I said, it's going to be HTTPS. It's going to be SSL. But I'm going to write or wrote a script that's going to attach to Firefox. It's going to check those functions, and it's going to read the clear text. So this is good. It's kind of a really classical example. So it's just going to do like really quick. Yay! Last time. Exactly. BDay. Where is Firefox? I have already. Oh yeah. Super secure banks is here.
Yeah.
Has the padlock.
Carlos Bank.
It must be secure. It has the padlock thing. Okay. And then I have this program that's just called HTTPS Stalker. Just say go to Firefox, and it says I'm inside your binary, I'm reading your clear text. So those are specific functions I've been invoked right now. And I'm gonna write here Carlos and super password for this person. Okay, he says, welcome Carlos, you have 1 bazillion euros. Cool. Fantastic. Then this is all the information you got. Here you can see the HTTP headers. And you can see here we have form URL code, username Carlos, password, nothing to see here. Because this is exactly the data that the Firefox put as argument to this function, and after this function gets executed in all of the other ones, the data is SSL. But I'm just exactly at the point before this happens. So again, this is a typical case for, I think, the Zeus or whatever banking Trojan. They did exactly this kind of thing. So it was actually very easy. Okay, so that was everything. Just a quick, very quick recap. Yeah. So when you want to modify, analyze dynamically binaries, you can have Python or this Intel pin, the C++. Python, you can do, like in Python, a fast prototyping. So it's really cool. You can do, it doesn't work, now it works. You don't have to compile. It's slow, yeah, because it's interpreted code. With Intel pin, it's really quick, it's really intelligent. You don't have to give the auxiliary file or something. But let's say it like this, like really nicely. That means it's fucking difficult. But hey, it's important. Yeah, and that's all. For coming, this is my Twitter, this is my email if you want to send me love or hate. Both are okay.
Spam.